Hello everyone. Today I am going to start analog electronic circuits, and in that one of the most important topic is BJT. Today I will just give a small introduction on BJT with one problem, and from tomorrow we will see each and every configuration in detail. So let's start. This is a basic sketch of an NPN transistor in common emitter configuration. Don't worry about the configurations, I discuss them in detail one by one. Just take it as an example today. So basically common emitter means when the emitter is grounded. So here I have grounded the emitter. And I will explain based on that. Now it is a NPN transistor. What does it mean by NPN? Now, in simple words, BJT is nothing but two diodes connected back to back, or to be precise, two PN diodes connected back to back. NPN, that's what it means. Now, the basic structure of a transistor is, it is a three-terminal device with a collector, a base and an emitter. NPN, which means collector is connected to the N junction of the diode, the base to the P junction, and emitter again to the N junction. So it's basically two diodes connected back to back. Just remember three terminals: the collector, the base, the emitter. Collector, base, emitter. Now here it is common emitter, which means the emitter is grounded. So there are three basic voltages in the transistor: the base emitter voltage defined by VBE, the collector emitter voltage defined by VCE, and the collector base voltage defined by VCB. So I hope it's clear. Now, since there are three voltages, there are three basic currents, being the base current IB, the emitter current IE, and the collector current IC. Now, the three basic principles which never change irrespective of the type of the transistor are here. IE, which is emitter current, will always be equal to IB plus IC. You see here IE is equal to IB, which is the incoming current, plus IC. So this is clear. IC is equal to beta IB. Now beta is the current gain in common emitter configuration. I will explain that tomorrow in detail. Just remember this for now. And IC is equal to alpha IE. The relation between alpha and beta is given below. Don't worry about this now. I am just telling you as a basic knowledge. I will explain each and everything in detail when we see one configuration. Now, the other important thing is VBE voltage should always be minimum of 0.7 for the transistor to switch on. Whenever you see VBE is less than 0.7, which means the transistor device is off. Just remember that. The minimum value should be 0.7 always. Okay. Now, there are two basic junctions in the transistor which define in which region the transistor operates in. There are three main regions: the active region, the saturation region, and the cutoff region. In active region, this particular transistor will act as an amplifier. That is the most important region of everything. In most of the applications, we have to make sure that the transistor is in active region. Now let's see about those 3 regions. Most of the questions in GATE are based on this concept. Now, my first junction is defined as the base emitter junction. The base emitter junction. So, J1 is base emitter, and it comprises of the N, which is the base, and P, which is the emitter. N is the base and P is the base and N is the emitter. And my junction 2 is the collector base junction. Collector base junction stands for N is the collector and P is the base. So now based on this, we have to see in which region it acts as a active, saturation and cutoff. Now if our junction 1 is forward bias, what is junction 1? PN. Forward bias meaning if VB is greater than VE, P has more voltage than N, then we say the diode to be in forward bias. So if junction 1 is forward bias and junction 2 is reverse bias, what is junction 2? NNP, which means VC is greater than VB. When the N region has more positive voltage than the P region, then it is said to be reverse bias. So if VC is greater than VB, it is in reverse bias. I'll write it down here, VC greater than VB. And here VB greater than VE. I hope this is clear. Next, saturation region. When junction 1, which is the base emitter region, is in forward bias and junction 2, collector base region, is also in forward bias, then transistor is said to operate in the saturation region. So in this case, VC will be less than VB. This will be the same. VB will be greater than VB. The third region is the cutoff region, when both junction 1 and junction 2 are in reverse bias. Transistor is said to be off in this state. I hope this much is clear for a basic introduction. I will give one small problem and then from tomorrow I will explain each and every configuration in detail. So let's see the problem. Just try to understand, I have taken a very simple problem based on what we have learned now. The transistor in the circuit shown below will operate in which region? Now we have seen 3 basic regions: active, saturation and cutoff. Now from this we can see it is an NPN region. NPN transistor. So let's see each, and it has 3 terminals, and we have to see the voltages at 2 regions, the base emitter and the collector base. So let's see. Option 1 they have given is, it is an active region for V1 greater than V2, but both V1 and V2 are less than 0. So if V1 is greater than V2, VBE will be V1 because emitter is grounded 0. So VB is nothing but V1. So V1. But they have given V1 is less than 0. So let's say V1 is minus 3. But which means P terminal is given a negative voltage, but the emitter terminal is 0. So V emitter is 0. So from here we can see that it is in reverse bias. Since the P region is given, Vp is less than Vn, it is in reverse bias, so it cannot be in active region. As we know, for active region VBE should be in forward bias. So option 1 is cancelled. Now let's see option 2. If V1 is less than V2 and both V1 and V2 are positive. So let's take an example. If V1 is 5, VBE will be 5 and VE is still 0. So junction 1 will be forward bias as VP is greater than VN. That is satisfying. Now let's see. Let's calculate VCB. VCB is nothing but V2 minus V1, as V2 is the collector voltage and V1 is the base voltage. So 10 minus 5 is 5, which is greater than 0. This shows that junction 2 is in reverse bias. So both our criteria is getting satisfied. So option B is the answer. Just go through this problem carefully, and tomorrow I will discuss the first configuration of common base. Till then, please like the video and share it. Thank you.